Hello everyone. I recently got this UPS from my work. They gonna throw it out because battery died, but I decided to bring it here and look what's inside and what interesting thing I might do with it. So let's just look what is inside. I already unscrewed there was 4 screws here, and on the other side, and that's basically it. There is no battery here. Battery was connected to this and these terminals. But it is completely there that worked, and it's just garbage. So what we got here? So this is main controller. It says MC68HC 705, and there was a sticker on top of it. Yeah, and this one is ULM 2004 and just a HA 1732. And this is a 5-volt stabilizer 7805, and just that's it. There's nothing interested. There's nothing more interesting here on this board. This is a beeper. I covered it with tape because it was incredibly annoying. And here we got main transistor switches. So I removed this top cover, and here we can see the PCB. This is our MOSFETs, and to 6 of them, and this one, I suspect they somehow connected in parallel to one another, but and here is our transformer terminals and a lot of relays, like 4 of them. And here is the transformer. The plus is going here, and this 2 is going to our MOSFETs, and a couple of these probably do something else. So let's just connect it to this power supply and see how it works. So here we got our test setup. I connected the battery terminals to this regulated power supply, and it's set to 15 volts right now, because when I turn it on, the voltage will decrease by a couple of volts, because it is quite significant load, and I will lose some voltage in this long wires which they go here. So I start it at about 15 volts without load, and we will see how it will drop when I turn it on. Here we have our test load, just regular incandescent light bulb, and it is also connected to the this cheap Chinese voltmeter, and just quick reminder, do not touch this. Here it got only 12 volts on the input, but it is a regular C voltage on the output, and you can easily electrocute yourself with this kind of things. So yeah, let's just turn it on. And here we go. You can see it says already 14 volts, and what we got here, says it not the proper voltage, but just that's just crap. So here we go. I will gradually decrease the voltage on the input and see what will happen. See? It is turned a little bit brighter, because now it tries to compensate the voltage drop, and it also starts this really weird sounds, because I suspect it is because the lead is too long, and the voltage quite dramatically changes on the input, because then it changes to the then it changes this relay, and the load is increased, and current on the input is increased also. So yeah, this causes this weird oscillation. Then we can see it changes the windings on the output of this transformer by the relays, and let's just move on. I hope, yeah. Now when we bypass this not stable point, the thing is basically it's just don't know what to do. It sees the voltage on the output is not enough, and then it changes the winding on the transformer. As you can see, there is a multiple windings on the secondary or primary. It depends on in which mode this transformer is working. Now it is this thick wire go to the primary, and this is secondary. So it is changing the winding here, because it is only one thing which it can do, because the voltage on the primary is our input voltage, so it just can't do anything with it, so it just changes the output, because there is only one primary winding here. And now we can see it shows, yeah, so it shows more on the output than there is less on the input. And now when I go to decrease the input, it will just give up at some point. Yeah, and the see the voltage is increased because the load is gone. So yeah. Now I soldered a couple of wires, one here and one here. To be able to see the voltage on the input of that transformer, and these two terminals is the primary of the transformer, and it goes to the scope. Now it both shows the DC input voltage from the power supply. If I turn it off, it will drop, yeah, it drops to the 0, so 0 is here, and now if I turn it on, it's a little bit strange. So just, yeah. So now, as you can see, then this one is pulled to ground. This one is nah. Let's just say it goes open, and now they both somewhere in between, and now they change. So now let's just change the voltage. Go to the stable point. No, just don't want to do this. Yeah. Now it changed, and it changed the duty cycle. So this one is open for longer, and now this one is open for longer. Any hidden patterns in it? Probably not. voltage. No, it don't seems like it is doing so kind of PWM here, because it just remains the same until this intermediate point that it's not stable, and just can't decide what to do. And now then I bypass it. Yeah, it's just the same again, and I suspect now it will try to do some kind of PWM, yeah. It definitely changed the duty cycle here, and yeah, so you can see it changes it somehow between here and here, but the pattern is basically the same. It is this open, this closed, now no one, and now they change, and same here, this one and this one. Oh yeah, but there is no this no intermediate state here, so they definitely do some smart things here, or at least they try to be smart, but somehow it works. Now it will it just gave up. I wanted to look on the waveform on the output of this thing, but there is a problem. I do need the scope which is not connected to the mains to do such a things, because otherwise I get all the ground reference issues, and let's just say the nasty things might happen. So the best thing I can do now is just use some AC to AC. No, focus. AC to AC adapter, which basically is just an transformer inside, and we use it to look on all the waveforms in the output. So now what I've done is I just connected output of this adapter to the scope, and this is completely safe in terms of ground reference, and here is our waveform. I'm not surprised to see this, because it just what we can judge by looking on the input of the transformer. Here is this distorted part. This is driven by one MOSFET, and this is driven by another MOSFET, and this is our not driven part here. So it it don't output the sine wave, of course, but it is not important for most applications, because the computer power supply, which is what this UPS is intended to drive, is start by rectifying input. So it will be just this peak, and this peak will be reversed here, so we just get this square peaks, and it will smoothen by the filter and the caps and filter, and we'll just get our DC in our computer power supply. But let's just change the voltage and see how it will change. Yeah, I hope I will be able to get to this stable point somewhere. Come on, you can do it. Just stop it, lady. Yeah, and this is just bizarre. Yeah, I would say the rectified output will be okay, but the waveform is it's just I don't know what to say. Maybe it is a result of such a long wires from the power supply or something like that. Yeah, and it just gave up. So that's it in terms of the driving this thing by the DC, low voltage DC input. But it's not the end of the story. I will drive it by the variac in next experiment. So here we go. This is my old trusty dusty variac. This is some proper variac wired with thick copper wire, and I connected it to this cable to the input, and there is no DC input in this experiment because this UPS is quite good, and it will I mean, for experiments it will start without this DC, it will start without AC. It basically don't impose any artificial limitations. I had another one which don't start from the DC unless I apply the input. So if the power is gone, I can't use it because I just can't start stupid thing. So then it's said, let's just press the button, and I don't use power supply here, only scope, and scope is the previous experiment connected to this AC to AC adapter, which is basically just a regular transformer, and that can be sure by measuring the weight of this thing. That's just simple transformer. So we see the voltage here, but don't have any issues with ground referencing of our scope. So let's just start. Yeah, and it will do it because it try to check the battery, and it doing it by applying some load to battery, and then it just fails because there is no battery, and it's just return back to the previous state, and of course we see beautiful sine wave here, which comes directly from the mains input. So what I'm going to do is, there is no knob here, it got lost somewhere, and I will just decrease the voltage and see what will happen. Wow. And at some point, and if I will increase it back again, so at some point it changed windings on the transformer, so it in this case it operates as some sort of stabilizer, and if I will decrease the voltage even further, it will try to change to the battery at some point. But there is no battery here, and it just turns off as a result. Said there is no additional winders, so it do this clicking thing only once, which is not enough for some situation, but what I can do about it? So if I try to start it here, it tries to start, but then it just changes to the battery, and there is no battery, so it just goes. And for someone who might wonder how this thing is charging the battery, I would say the answer is quite obvious. It has a transformer, and it has this MOSFETs, and it just then the voltage on the input is okay. It just use this transformer to charge the battery, because this part got connected to the mains and works as input. There, this wires works as an output, as a secondary winding here, and it just use this voltage to charge the battery. So there is no separate circuit or transformer to charge battery in UPS, because there is no need for it.